Hello everyone, this is Terrence, and today I'm making my video on about the maillard effect. So we cook every day. It's a process that we do to survive. We need to cook so we can sustain ourselves. But you never really think about the chemistry behind it, on why when you cook meat it smells so aromatic, why it changes colors, and today I'm going to talk about the chemistry behind it. So some background is the Maillard effect was actually founded by Louis Camille Maillard. He was a French scientist in 1912 who published a paper describing the reaction of amino acids and reducing sugars during heating, which resulted in a browning effect of many foods. So, to get into the chemistry of it, the reaction begins with the carbonyl group of one reducing sugar and a free amino acid or protein. So, for my demonstration, I used 2 eggs, tongs, some chicken. I also used some baking soda, and also I had a pan and my stove. And to remind you, a reducing sugar is a sugar that contains an aldehyde group or a ketone group. Furthermore, common reducing sugars that are found in many Maillard reactions are glucose and fructose. And common amino acids that are found in many Maillard reactions are lysine and glycine. And amino acids are just, or like proteins are just amino acids in long chains. So to begin this reaction, I'm putting chicken onto a hot pan with oil. So typically it takes up to 121 degrees Celsius and to 177 degrees Celsius for the Maillard reaction to take place. So while I'm putting on this chicken, I'm waiting for it. I'm gonna speed it up and wait for it to cook. You can tell the Maillard reaction is occurring because the outside of the chicken is beginning to brown, and there's actually another way to speed up the reaction without using heat, and this is by increasing the pH of the environment by adding a little bit of baking soda because it is basic. It speeds up the reaction because it makes the nitrogen and amino acids of the chicken more neutrophilic, meaning that they are more likely to attack the reducing sugars, binding with them more often. For the next part of this demonstration, I'll be using 2 eggs to demonstrate how the Maillard reaction works on these 2 eggs. So I'm going to have a pan, heat it up, crack 2 eggs into it, and then let it cook for a little bit and flip it, and you can immediately see the browning. This is because the reducing sugars and the amino acids of the egg are reacting with each other to form compounds of the Maillard effect. I hope you enjoyed my demonstration and you learned a little bit of insight on what happens every time you cook something. That is because of the Maillard effect.